Hello everyone, this is Jung Jung. I will explain Introduction to Data Structures. Today we will study Chapter 5, ADTs, Stacks, and Cube. This figure shows the stacks of coins and the bills. Also, we can see stacks of boxes, stacks of books. So the top one is called the top of the stack. This book stack is also top of the stack of a book. So definition of a stack, logical or ADT, abstract data type level. A stack is an ordered group of homogeneous same types items elements in which the removal and addition of stack items can take place only at the top of the stack. So that's why stack is called LIFO, last in, first out structure. Stack ADT operations make empty is pull, push, pop, item top. Okay, so looking at the stack top item. Okay, so this figure shows a class interface diagram. So stack type class. Okay, in the middle we have a private data. Top indicate the stack top item, and stack has items array. And also member functions such as constructor stack type is empty, is full, push, pop top. Pop on top. ADT stack operations. We have two kinds of operations. First one is transformers such as push and pop. The other one is observers such as is empty, is full. We will see one step at a time. This source code shows class stack type. So we have public member functions here. Constructor is full, is empty, push, and pop. In private case, the top, this is a private function, and the private member variables is a top index and the items array for stack. So what are the pre and post conditions? This is implementation of stack type class. This header file, and this is constructor case. We initialize stack top index -1. So 0 is the first item in array. So -1 indicates empty, and is empty. We can compare. Top is equal to -1 is true. Okay, otherwise false. And is a full case also max item -1. The index case is full. And the push case is a pull case is through error handling. So it's going to pull stack label we can handle. We print out the stack is full, and otherwise we increases top index, and then we can add on new item into this one. Remember, new item is the integer. Okay, and or a character. Pop case is empty case. We can handle this error. We jump to the label called the empty stack. We print out stack is empty. Otherwise, we decreases stack top index by this -1. And top case we if empty case, we handle error case. Otherwise we can return stack top item. So we can take one example tracing on client code. This is a value of a letter character, and this is a private data top index. This is a stack items array. So we perform this one, the letter, the variable initialized with v, and we create stack type character stack class object here, initialize top index -1, and then the push letter, this v, so we can v, and then items array, this top set to 0, also item is v, and the C case we can add one, the S case we can increase the top index 2, also stack third one is S. The is empty, we check. Okay, this is empty, is not true, right? Is empty is not. Okay, so in that case we can empty is not, right? That's why we can call pop. So the previous one is the top decreased by 1, also we can pop. Okay, and then push again, and then this we increases this one by 1, and then top character previously S, now we K. Okay, and then empty, this loop is until this stack becomes empty, we can check the letter and the pop. Okay, so not empty, right? So empty case true, and then okay, empty is true, and then the pulse and the exit. Okay, but this is not empty case, execute inside this brace, okay, code. So top is 2, right? So character is letter is K, and then we pop, decrease this one, and then we can not empty, and then we can okay pop again, and the stack comes right 0, so just the one item remain 0. Okay, and then we can check not empty, and then pop, and then stack top index becomes -1, and then stack is empty. So empty, empty, right? And then this one is false, and exit this while loop. Okay, so another stack implementation, one advantage of an ADT is that the implementation can be changed without the program using it knowing about it. The dynamic array implementation of a stack has a weakness. The maximum size of stack is passed to the constructor as a parameter. Instead, we can dynamically allocate the space for each stack element as it is pushed onto the stack. Okay. In the same way, if we pop, we delete. Okay, dynamically. Okay, this figure shows the another version class stack type using a linked list. Okay, so top pointer point out the stack linked list. Okay, so we can use the floating number, the previous character, also string we can handle. Okay, so let's take a look tracing client code example. So here variable letter, and then this is a sequence of function execution commands. So initially stack top is null, okay, when we make the my stack object. Okay, and then we can push letter first 1 V, and then C next, and the S third one. Okay, it's a not empty case. Okay, we can check a top and then pop. This is pop character, and then next pop not empty, next one is C. Okay, not empty, and the next one is free. Okay, this becomes empty. Okay, and then push again, we generate another node here. So this is the class specification of stack using linked list. So public function is previous array based one is right, can be used, but private case, instead of top index, we can use a top pointer, okay, to point the first node of linked list in the stack. And node type structure is consists of info, item type is integer, and the next is node type pointer. Okay, so adding a new item, right? So remember new item, this is we defined item type dot h, this is the integer. Okay, so this item type is type depth as integer. So new item B, okay, integer case, character case we can take, okay, and then we create a node. So this character bracket a character we can use it, or without this one also fine, okay. So node new type case also fine, and then create, and then location indicates new node, and then we initialize the info with the new item B, and next is a top pointer, okay, and then we adjust, okay, top pointer point location, and then we can make like this, okay. So initially we have this kind of 3 item, we insert the B. Let's take a look, okay. Location, initially garbage value here, and then we create, and then new node location point to new node, okay, and then initialize this one. Initially this is garbage, and this one is okay, set to B, and then pointer, this one is location next, set to type top pointer, this person node, okay, and then top pointer is okay, adjust with the location, this one, okay, and then top is point B new node, and then this B's node point to previous top's first node, right, and then we adjust, okay, stack link list, okay. So implementing push, okay, stack type push as new item to the top of stack. So we can check is a full or not. Full case we handle full stack, okay, label this true, and we can catch this one, handle this full error. So linked list case, actually we can handle create a new one, and then we delete, okay, and then if there is something wrong new to create a new object, handle catch the error, okay. And location, so this is the temporary variable to point out new object here, and the initialize location info next, and then adjust the top pointer with the location, okay. So do we need is full? Actually it's not, okay. We handle this new allocation, but this is a mimic to previous address array based stack. So deleting item from the stack here, okay, temporary pointer. So okay, item is okay, import integer type, okay, stack top information B, and then temporary pointer point the first stack top node, okay, and the top pointer, this is point to this node next, this one, right, because we deleted this one, right, pop eventually, and then delete this node, right, okay, deallocate. So implementing pop and top, pop case we can check is empty, not empty case here, so we can do the previous code, right, and then top case is empty case, we can through empty stack print out the error message, otherwise return top pointer info value. And the is full, so we discussed, right, so location try and catch, okay, so we try to allocate and then delete, okay, so there is no problem, not full actual physical memory, otherwise this new node creation has problem, standard bad allocation exception handle call, and then return true. Example of a queue, so we saw the stack, now queue case the waiting list line, okay, so this is okay library, so in front of queue, okay, we can borrow or return textbook, so this is a rear queue, okay, so queue case front case, this is the exit, the rear is the entrance, okay. So what is a queue? Logical or ADT level, a queue is an ordered group of homogeneous items, elements, in which new elements are added at one end, that is a rear, and elements are removed from the other, and it is called the front. A queue is called the FIFO, first in, first out structure. So let's take a look queue ADT operations such as make empty, is full, in queue, dequeue. In queue case, we add the new item into queue. DQ case we take out, okay, item from queue. So we have ADT queue operations, two categories. The first one is transformers, such as make empty, in queue, and DQ. The second category is observers, such as is empty, is full. So this figure shows a simple array-based implementation of queue. So we have an array, and then the front indicate, okay, one reserved index of the first inserted one. Rear case, this last one. Okay, so we can using this one, and the max queue is the size of queue, max queue. So public interface of a queue type. Okay, so type depth, item type now is character, and this is a queue type class. So public functions constructor have two, default one, and if parameter max size of a queue can be specified, and then destructor, and make empty is full in queue DQ functions. So what is the private part of class queue type for this design? What troubles do we encounter? And dynamic array implementation case, we can using dynamic allocation. Okay, so what is the private part? Class queue type for this design. Does this design have the same problem as the previous design? And also we can make a linked list based one case. Okay, we can using the front is front node. Instead of it, queue rear case point at the last item in the queue. So what is the private part of class queue type for this design? And also we can inherit queue type and make counted queue type. Okay, so this one is base class. This is inherited class, new class. Okay, so public, and then we can this class name. Okay, the in queue DQ get length, return the number of item on the counted queue. We can count the number of item queue. What additional fields does counted queue type need, such as length, the number of items? What functions must be changed? So lastly, this figure shows queue contains 80 byte string. Okay, this one. So element queue. Element queue, and this is byte, right? If we are using array case, queue case always the same. Occupation of memory. Linked queue case, the number of element, and we can linear increases occupy the memory. Something. And secondly, queue contain 2 byte integer case. So previous 8 byte strings. And this is a 2 byte integer case. Also we can measure. So over the number of elements, array case always the same. This one. However, the linked list is linearly increases. According to the figure, so linked list based one is more efficient in terms of memory usage. So this is the end of this class. So if you have a question, please let me know. Thank you for your attention. Bye.